The U substitution is a very powerful technique that you can use when doing integration. Sometimes you're given an expression or a function that you have to integrate, and when you look at it, you can't find your way out. But if you do the U substitution, it becomes very, very easy. I'm going to illustrate this using these two examples that I have before you. You may find that there are other techniques that you can use instead of using the U substitution, but in most cases, or in some cases, it is the only way out, especially when you're confronted with quite complicated integrals. Okay, let me start with the first example as an illustration of how you can use the U substitution. So you're gonna get this from experience. If you practice and practice and practice, you will quickly realize that, okay, if I'm given this function or if I'm given this integral, this is how I should proceed, or this is where I need to use the U substitution. Another technique again, or another thing that you should look out for is who to make the U. Who is going to be our U? Like in the case that we have here, I'm going to choose x plus 3 as my U. You're going to find that if you choose a root of x plus 3 as your U, you can still get it right. You can still get it right, but maybe it can be a bit complicated. I'm going to use x plus 3 is my U. So U is equals to x plus 3. U is equals to x plus 3. From here, I'm going to look for du dx, which means here du dx is equals to 1. I simply differentiated x plus 3 with respect to x. From here, it also means du is equals to dx, or maybe dx is equals to du. We need this because we want we're going to replace our dx with a du, so you should do that. Then but if you substitute your u back into this function and you also substitute your dx back into this function, you will still remain with an x. This x here will still remain, but we cannot integrate in terms of u when we have an x there. So we should have a way of removing the x so that we only have u's. We rely again on this function here. From here, we can make x substitute of the formula, which means x is equals to u minus 3. If we do this, then we can go ahead with our integration. So where there is x, I'm going to put u minus 3. Where there is x plus 3, I'm going to put u. And where there is the x, I'm going to put du. And then I do my integration. Let us continue. So this is like from here, we can say that this is equal to the integration of u minus 3, the root of u du. Now what we have now is quite friendly. We can work with it, and so we are integrating. I'm going to rewrite this as u minus 3 to the power of u to the power half, like this, du. Right. From here, we can multiply out this, or we can simplify this part here. We can simplify this. If we simplify that, it means we're having, this is the integration of, if you multiply u to the power half by u, you get u to the power 3 over 2 minus 3 u to the power half du. Now what we have here can be integrated easily. It's just a matter of adding 1 to our power and dividing by the new power. So if we add 1 to 3 over 2, we get 5 over 2. So this is like u to the power 5 over 2 divided by 5 over 2 minus 3 to the power 3 over 2 over 3 over 2 plus a c. So we have done our integration and it is proper. Now we just have to put back our u in terms of x. So we're going to just, where there's u, we're going to replace it with x plus 3, and we're just going to simplify what we have here. So the final answer will be, let me use a yellow pen, the final answer will be 2 over 5. Then the u here is x plus 3, so this is x plus 3 to the power of 5 over 2 minus 2 x plus 3 to the power 3 over 2 plus a c. So this is the final answer. This is my final answer here. This is how you use the u substitution. It is quite a very straightforward method. As long you are able to make the right choice of your u, you easily do this integration. Let me move to the next example of the u substitution. Let me come to this example here. We can also rely on u substitution on this one. Now I'm going to choose ln cosec x as my u. Ln cosec x is my u. Therefore, u, so let us go here, u is equals to ln cosec x. Du dx from here, du dx is equals to 1 over cosec x times, if you differentiate cosec x, we get, if we differentiate cosec x, we get minus cosec x cot x, which we can simplify to be, if we simplify this, we get minus cot x, minus cot x. So du dx is equals to minus cot x. Du dx is equals to minus cot x. Yet from here we can conclude that our dx, therefore dx is equals to minus du over cot x. We need this dx in terms of this u because we're going to substitute it back into our original. Now let us substitute back. It means from here we can go to say this is equals to, so this is equals to the integration of minus ln, not minus ln, minus u to the power of 3, so minus, where there's ln cosec x, I'm putting my u to the power of 3 times cot x times, where there's dx, I'm replacing dx with minus du over cot x. So minus du over cot x. So from here, I can simplify this. I can cancel this one. And this minus here and this minus, and they can multiply each other. And it becomes positive, which means we are essentially integrating u to the power of 3 du. If we integrate u to the power of 3 du, we get u to the power of 4 over 4 plus the general constant c. Now, to finish off our integral, we just have to replace the u by ln cosec x because we agreed that our u is ln cosec x. So it means here we have ln cosec x, ln cosec x to the power of 4, all this over 4 plus c, the constant. This is how you use the u substitution. It is a very powerful technique. It is very effective. You just need to do a lot of examples, a lot of practice, and sometimes when it comes to integration, the trick is your ability to see the best technique that you can use in that. Because if you don't see that you have to use the use substitution, you may take time or you may take longer to finish a very simple question. Thank you for watching the video. If you have any questions or any comments, just write in the comment section below. Otherwise, give the video a thumbs up and share with your colleagues.